Howdy folks, today we are going to be looking at database pagination. And you might be wondering why do we need to paginate our database unless we're doing something with an API? Well, sometimes you have situations where you just need to fetch all the items in your database, but if you do that all at once, it causes a lot of problems. Let's take a look. So here I have a very simple database object. Has table objects and just has a string field that's a string of size 100. I've pre-populated this table with 2 million rows, so it's got a decent bit of data in it. You might think 2 million rows is the most that you're ever really going to run into, but if you work at some of the bigger companies on some bigger projects, it gets quite large. And so I have a script. This is meant to be a CLI script to maybe run to fix some issue. Maybe it runs as a cron job every night. And it's pretty simple. It basically fetches every single object from the database, gives you a little bit of information about it, loops over every single one of those objects, and performs some operation. You might think, gosh, over 2 million objects, this can take forever. Well, that's probably why we'd run it as a cron. This is the sort of thing that you'd run and you'd expect it to be taking maybe 3 or 4 hours in the middle of the night. So let's go ahead and run this. See, it connects, and then we get a crazy bunch of errors. What's going on here? Well, it ran out of memory. And the reason it ran out of memory is it tried to pull so many things. I am specifically limiting this to using 200 megabytes. But that is not an unrealistic expectation, especially if you're at a big company. You might have multiple scripts running. Maybe you've got a bunch of crons running in the middle of the night and you don't want to overload your servers, or maybe all the crons run on one server and there's limited CPU to go around, limited memory space, so I've limited to 200 here. If I run this without that limitation, you can see it's taking a while. You can see it loaded 2 million objects and it took up 658 megabytes of memory. That's actually kind of a lot of memory. That's my whole database, and you can imagine I have 20 million objects, which is not unrealistic. That'd start using up 6 gig of memory. I can't have a single process taking up 6 gig of memory. That's just way too much memory. So how do we get around this? Well, what we want to do then is, it is kind of similar to if you're paginating via an API, but you want to paginate with your database search as well. So to start off, I'm going to start off and declare a current. So there's 2 ways of doing this actually. So we'll look at the first one first, and that is just using a limit and offset. So I'm actually going to declare page size, and let's say we do 10,000 to start with. Oops. Let current page is 0. So now what we're going to do is we're going to have a while loop. You know what? Let's use a do while loop, and I'll show you why in a second. And we'll put our condition here, some condition. Okay, so inside this loop, okay, we're going to continue to do that same search. And in this case, I want to order this by the ID. And then I'm going to put my limit, which is the page size, and then my offset is going to be my current page times the page size. Because your offset needs to be, like, you can't just give it a specific page, it needs to be 2 actual numbers. Now, what I'm going to do is I'm going to say while objects length is above 0. And what that means is I'm going to loop on this until I run out of objects, basically the database, and I'll actually say current page plus equals 1. So what's going to happen now is the first time we loop through this, we're going to grab 10,000 objects from the database, and our page is going to increment by 1. Then we're going to say, okay, we increment that by 1, we come through again. The next time we're going to be incrementing again and getting 10,000 objects, but we're going to offset by 10,000 now, because our current page has been bumped up by 1. And we're going to keep looping on that constantly until we get through all 2 million. Hopefully, the idea here is as soon as we don't get any objects, i.e. our page has gone off the deep end, we're going to get one final query where we don't have any objects at all because there's nothing left. And at that point, then this loop should terminate. So let's give that a try. Oh, bad field error. Count 0 in order clause. Oh, you know what? Because this actually needs to be an object. And I want to actually order by ascending. The order is important there. Uh-oh. Oh, that makes sense. Actually, it says, hey, I don't know what objects is. Let's define that outside. It's just an empty array. And that's just because this while loop doesn't have really access to things that are inside of it, which I feel like it should, but just how it is. And so now you can see we're looping through a lot of these. It is taking more time, rather. You see, every single one of these, the last time when we actually loaded all 2 million at once, it took, you know, not super long to grab it all in. But then after that, it took a little, it took more memory. So in this case, you know what? I feel like I might actually be infinite looping here. Let's just see. Let's get a total here. Because really, it shouldn't go beyond 20 pages, I think. Oh no, actually, let's do 100. I think 100,000 we can handle, and that should do 20 pages because 10 is going to be slow. Oops. Okay, and that's still not using too much memory. You can see we're using a fraction of what we were doing before, and we're well within line. Okay, let's just make sure that this ends. Okay, cool. It does end. Yeah, so you can see if we did 10,000, it took way too long because there's 2 million users or objects. So that is something to keep in mind when you're doing this. You do have to really take into account how much what your page size is going to be and make sure it's something that's reasonable. Okay, so that wasn't too bad. We got all that stuff. We ran the same complication, assuming this took over, 2 hours to do the actual operation. And that's totally fine. You may need to structure your code in such a way that you can handle, you can handle it in pages, because sometimes if you have dependencies in between the objects, that can be a little difficult as well. But hopefully you don't run into code with that. Now, what is the downside of this? Well, the downside is, for one, this part is actually really important. I just want to talk about that real quick. If you're not ordering these correctly, the database kind of makes up the ordering. And that means you probably aren't going to have issues, but you might end up with strange bugs where an object gets returned twice for some reason, because it's just the database decided to switch the ordering halfway through, like maybe something else got inserted. To make sure that doesn't happen, you want to make sure you order it. So that's the first one, is using that limit and that page size. However, the downside of this is on certain relational databases, the database actually, to get to this offset and this particular page size, it has to go through every single object. Okay, and it actually has to scan all of them. And if you're working in a distributed database system, that can actually be really expensive, because it means that every single system will run through all these rows and give you a bunch of stuff. So this actually, for extremely large distributed databases, is not recommended as the way to go, because it actually causes a lot more work for the database. Well, what do? What we can do is we can actually use an offset key. So in this case, I'm going to use the offset ID. And in this case, what you do is you actually want to get a check to make sure that you're getting all the elements that are greater than this offset ID. So to do that, I actually want to build a where builder, because I can't do that complicated of a parameter in here. New dot, oops, oh, that's not the format. That's not the format either. Compare, okay, now I'm going to get my string, or actually my ID, and then compare dot greater than, and then my offset ID. And I'm going to pass that in to here. So what that's going to do is that is actually going to make sure that I'm still getting this page size here, but I'm actually going to get rid of the offset. And what that's going to do is that's going to get me now another 100,000 that are greater than this offset ID. Again, we're sorting by the ID. Now, instead of incrementing the current page, what I do is I can actually say offset ID equals object.id. So this means that I'm going to loop through all these objects. Offset ID is going to be set to the very last one. And then the next loop around, it's going to say, okay, well, get me another 100,000, but make sure that their IDs are greater than this ID. You could see it still kind of does the same thing. It's still getting me 10,000 or 100,000 objects each loop, and every single time it's getting the next chunk of them. And I'm guaranteed to have a unique set because I'm ordering them by ID. But what this does is it means the offset parameter is no longer there. And this means for some distributed systems, the system can more effectively actually do computation because it's looking at an actual field. So that means that it can use indexes and use its own memory and bring that into play and figure it out because it's actually doing field comparison as opposed to just an offset comparison. So if I run this, oh, current page is not defined right. Just put the offset ID in there then. Okay, so you can see now it's doing kind of the same idea. It's just having this specific, and it runs about the same, and this last one got 0 objects. Perfect. So you can see it's basically the same concept, except now it's using an offset key. And this doesn't have to be the ID. If you have something else that you can guarantee is unique, you could use that as well. The reason you want to use something that's unique is because if I used something that maybe multiple objects shared, I run the risk of returning more than my page size, or specifically actually because I'm limiting on that, I run the risk of missing fields. Because let's say that I've got 10,000 objects and I'm going off of the name, and maybe 50,000 people have the same name, Tom. That means that depending on where that page boundary falls, I might actually miss people that are named Tom, and then the next time, of course, I'm not going to look at them anymore because I'm using this greater than comparison. So you really want something that's unique for doing this. Anyway, that is how you handle database pagination for when you really need to. This also does work for API pagination, by the way. So you can do this exact same thing if you've got APIs. You just are passing this offset ID back from the API and into the API as a parameter for the next page, or you're using page and limit, which is common. So again, the idea is that you use a search, either you have a pagination, you have a page size, but either use an offset and increase that offset every time, or you use a specific comparison against a unique field, usually an ID, and keep track of the last one that you process this loop, and then make sure the next loop is using a greater than on that. I hope this is interesting, and I'll see y'all next time.